so today, starting with box plots and histograms. Hopefully we've done these before. Okay, so today's the 22nd. So we're going to start with a frequency histogram. And a histogram is, it's like a bar graph. Except bar graphs have spaces in between the data. A histogram does not have spaces. Does not have spaces between each bar. That's your useless fact of the day. Difference between a histogram and a bar graph. Yeah. All right, so can you guys hear me better now? We're all good. Sorry, yeah, I was just quiet because my volume was down. Okay, so what we're going to do first today is we're going to take this data. Belinda collected all this data for us for girls and boys. Does the group Rook? It should be the group Took, sorry. My typing, yeah, to complete a 100-meter run. So these are the results, and they've got the girls' results and the boys' results, and there's 40 data points total. And what we're going to do is we're going to complete the frequency table. So we have to figure out how many girls ran between 11 and 12 seconds, and how many boys ran between 11 and 12, and we'll work our way all the way down and fill out the table. So why don't you guys go ahead and start working on that. Yeah, and what I would recommend when we're doing a data set like this, whenever you're doing this by yourself or something, I would say go through and cross them out as you're looking for them. So for example, starting with the girls, looking for 11 to 12 seconds, I just scan the data really quickly, and I didn't see any, so we're going to say 0. For the boys, I see an 11.8, 5, 11.8. Oh yeah, and I put this in order from min to max, so actually that makes it really easy. So the boys will be 2. But then just cross them off as you go. Okay. And then we'll go ahead and do the girls on 12 to 13, none. The boys, 1, 2, 3, 4. All right, and go ahead and we'll fill out the whole thing here, all the way down. Three, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11. Oops. So you gotta be careful on one of them here. Like I see for 14 for the, 14 for the boys, I should say. Because they have a, they have the 14 exactly, so that should actually go into the previous column. So we gotta be careful with that point right there. It should technically go in this column. So I almost fell for that one myself. So be careful when you're doing that. So there should be 8 on that column. Okay.
Mr. Street,
Yep.
for 19 to 20, you wrote 0, but there's one value of 19.
Oops. Yeah. There's a value of 19. So what happens though with that one, this is another similar situation. So there's the 19 right there on the girls' data. It's going to fall into this column here. So we should have 4 for the girls instead of 3. Okay.
Okay.
Yeah, because this one's strictly less than 9 or greater than 19 for T on the next column. Yeah, that one's kind of tricky. Okay. All right, so hopefully we got all that written down. Check your numbers with mine. It gets a little small at some points, but that's the idea here. Okay. All right. So I just gotta text Mr. Ford real quick. Yeah. All right. So next we're going to draw a frequency histogram for the girls and draw a frequency histogram for the boys. So what I'm going to do down here is I'm going to create one side by side. So we'll draw something that looks like this. And we'll call this one the girls' data. I'm just going to highlight that in blue. And we'll do the boys' data in green. All right, so whenever you're doing a frequency histogram, you want to find the value that's the highest. So for the boys, I had a 10. For the girls, we had a 10. So those are the frequencies. Okay. As far as the times, that's the other important factor we want to look at, which is going to be true for both tables. The time goes from 11 to 23 seconds. All right. So what we want to do then is we want to say, okay, we're going to start our histogram over here. I'm going to, let's see, get the blue out here. When you start your data, put 2 lines on the x-axis like this, because what we're going to do is we're going to start the y at 0, because the frequency could be as low as 0, and it's going to go all the way to 10. So we'll say 1, 2, 3, just go ahead and label up to 10. And we'll do this on both the blue and the green. Ten. Okay, and again, we're going to put this little x, or these double lines here, and that's because on the x-axis, we're not talking about frequency, we're going to be talking about the time on the x. And our time's not starting at 0, it's going to start at 11. So that's why we put that little line there, to show that we're not starting at 0. And we go 11, 12, 13, all the way up to 23. Ooh, it's going to get tight here. Okay. And then we do the same thing for the boys. Sorry, my handwriting's getting real small.
So it starts at 12 for the boys?
It should start at 11 for the boys. 11. It should start at 11 for both of them, just because they're both starting at 11 up here and going to 23 over here. Okay. Okay. And now for the data part, we start with like the girls at 11, they had 0, so we don't need to put anything down. At 12, they had 0. At 13, they had 2. And that was 13 to 14. And then at 14, they had 5, so we go all the way up to 5. At 15, they had 8. So we're going to go up to 8. At 16, they had 10, so we go all the way to the top. At 17, they had 6. Yeah, if I had a straight edge, this would probably look a lot nicer. At 18, they had 4. And then they had 0 at 19, 2 at 20, 2 at 21, and 1 at 22. And that's kind of what my histogram data is going to look like for the girls. And then I'm just going to use my highlighter and color it in, make it look a little pretty. But big difference between histograms and bar graphs. In case you were ever curious, I'm sure you were asking yourself this morning at breakfast, what is the difference? Now you know. Histograms don't have a space between them, between their data. Bar graphs typically do. Okay. There we go. There's our nice, lovely, ugly drawn bar graph for the girls' data, or histogram for the girls' data. And then for the boys, we just follow the same pattern. 2, 4, 8. So go ahead and draw your histogram for the boys' data. Up to 10, down to 7. Zero, 0, 1, and then we're done. All right. So I did run out of a little space, so I only took the boys up to 21, but technically it would go to 23. We wanted to match the other information. Okay. Okay, so I've got my histogram drawn. Part C says the PE teacher was interested in times of the boys and girls of the 100-meter run. So I don't know what I was doing last night. I was up way too late. It says company times. That should be comparing times. I've just got some typos on here. Sorry about that. The boys and girls find the following information. So we want to find the fastest time for each gender. So the girls' fastest time was 13.5. The boys' fastest time was 11.5. And then we want to find the slowest time for each gender, 22.5 versus 20.5. Those ones are the easy ones. Find the median. How do we find the median? That's a type of center. So what do we do to find the median? It's my favorite type of center because you literally just go to the middle of the data. So there were 40 data points. So it's going to be, if I'm looking at the very top of my data set, I'll get the highlighter out here. The girls' data, 16.3, 16.4. It's going to be halfway between those two, since there were an even number of data points. So technically, it's going to be 16.35 is your median. The boys, something similar. It was 14.3, whoops, and 14.5. So their halfway point is going to be 14.4 for their median. Okay. And now if we want to find the lower quartile and the upper quartile, we just split it again. So the top half is 20 data points. We want to find halfway in between those 20 data points. So we want to get out to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be halfway between 13.2 and 13.5 for the boys. And for the girls, it's going to be halfway between 15.3 and 15.5. That's how we identify the lower quartile there. Sorry, I went kind of fast there for identifying the quartiles. Does anyone need to see that again? Or are we doing okay with it?
Can you do that again?
Sure. So for the median, we find halfway between the data. So there was 40 total points. So the median, like I said, for the girls was going to be between 16.3 and 16.4. Now, the quartiles means we're just doing half of that. So it's halfway between the beginning and the median. And that's how we found this right here, the 15.3 and 15.5. So that's like the 10th and 11th data points. So we just split the difference. So we take 15.4. And then we do the same thing with the boys. 13.2 and 13.5, split the difference. So it becomes 13.35. And then one more time we do it for the lower quartile, which in this one is 17.8. And for the boys, 15.75. Or so the upper quartile, I should say, not the lower. And that's how we find their information for different points of the race where the information falls. Okay. And those are always important points to find. We call those the 5 points. So you find the min, the max, the median, and then the lower quartile and upper quartile. And those 5 points are important for what we're going to do next, which is drawing a box and whisker plot. Okay, so we just did the histogram. Now we're on a box and whisker plot. And a box and whisker plot, you need those 5 points. And your
Mr. Street.
Yes, question.
Ruby got kicked out and she's in the waiting room.
Yeah, I'm just making her wait. I'm so sorry, Ruby. I made you wait so long. My apologies, Ruby. Yeah, if I don't look up at my screen, I don't see that you're in the waiting room. So bad. Okay. So you need 5 points to draw a box and whisker plot. I'm just going to call it a box plot for short, but it's the same thing. So the 5 points are the min, Q1, which is the lower quartile, the median, Q3, and the max. Those are your 5 points. And that's what we just found in part C for the girls and boys data. Okay. If you have those 5 points, you can draw a box and whisker plot. So, of course, to make it more fun, With example 10, we're just going to have a new data set here, and we're going to draw a box and whisker plot for the females versus the males here. So for the females, I'm going to highlight in blue. Whoops. Okay. And then for the males, we'll highlight in green. And we'll create two box and whisker plots based on this data. All right, so saying that there's data for shoe sizes of group of students is shown in the table. So first thing we want to do is find out like how many of each type there are. So like females, how many total participants are there? So we say there's 2, 4, 14, plus 8, 22, plus 7, 29, plus 3, 32. So there's 32 females total. Okay, that's the first thing we want to do for identifying these points. We can identify the min and the max pretty quickly, actually, because the min is going to be the shoe size. Oops, undo. The min's going to be shoe size 32. And the max is going to be shoe size 40 for the girls. If we want to find the median, we got to go 16 data points in. So that's why I counted there were 32 total females. I'm going to write that in red here.
I thought the mean or the minimum was 34.
Yes, I'm sorry. The minimum is 34. Yeah. Thank you. I don't know where I got that 32 from. Okay. Thank you for catching that. That makes it a little easier. Oh, man. Oh, man. Okay. So the minimum is 34. All right. So now, since we know the min is 34 and there are 32 total participants, we need to go to the 16th spot. So we know that size 34 is the first 2 spots. Size 36 is up to 4 spots. Size 37 takes you up to 14. So the median is going to fall pretty solidly in 38. Okay. We don't know which one of those people it is, but it's going to be in the 38 category because that's the 16th participant is in that frequency zone. Okay, does that make sense how we find that median there? Okay, now if we want to find our Q1, our lower quartile, it's going to be halfway between the 0 and 16th participant, the 8th participant, which that's going to fall pretty solidly in the 37 range. And then we want to find our Q3, and that's going to fall into the 39 range. And that would be our representation of our data here. Now, whenever you do a box plot, you're just going to create a, yeah, I'll do this in black, the actual border at least. We'll create a graph here, and we'll just do shoe sizes. And we'll start with size, let's say 30, even though it's not on the graph, 32, 34, 36, 30.
Isn't this just the box plot?
What'd you say?
Isn't this just the box plot?
This is
like
the
that one square in the middle.
This is the box plot. What'd you say?
Like, isn't this like in the box plot? So it's like there's just that square in the middle, then the line, and then the line, and the line, and like the line.
You got it. That's right. So we're gonna go to size 34 as the minimum. So we draw the we'll draw the line on size 34 for the girls, and then it's gonna go all the way up to 40 for the girls. That's the other line, and then the Q1 is gonna be at 37. So that's how you know where the box starts. 37. Start the box. 38 is going to be our median. 39 is going to be the end of the box. That's our box plot. So you guys have done them before. That's good. Okay. For the males, there are 10, 22, plus 12, 34, 35, 36 participants for the males. Okay, but go ahead and right now, why don't you guys go ahead and do the box plot for the males? I got the males plotted. You should have your minimum as 36 or 37. Sorry, your maximum as 49, and then your Q1 should be 38. Your Q3 should be 40, and your median is 39. So that's kind of what we got for the males. Okay, for your five point summary. Okay, or the 5-number summary. And we always want to find that 5-number summary whenever we're doing a box plot. So the next part says state whether the box plots are symmetrical. So when we're talking about symmetry, we basically want to look and see, like, the box itself. Is the median kind of in the middle of the box, or is it like skewed to one side or the other? Okay, that's kind of what we're looking at for this one. So for both of them, like the females, we had the numbers went 37, 38, 39 for the box itself. That's pretty symmetrical. And for the males, it was 38, 39, 40. So that's also symmetrical. So these ones, even though they have long whiskers, these are still symmetrical. So both appear symmetrical. And we're just basing that on the box itself. But what we're trying to look for here is something called skew. So we're going to see, is it skewed to the left, which is going to be like some outliers are really pulling the data that direction, or is it skewed to the right? Okay, that's what we mean on that. And then the next part, comment on whether you think there are any outliers, or actually not even when we think there are outliers. There's actually a way to find outliers. So to find outliers, let's talk about that.
But they don't really look that symmetrical.
So when we're talking about symmetrical, we're talking about the box itself, not necessarily the whisker. Okay, so you're looking at, is the median kind of in the center of Q1 and Q3? And in both of those, they are. Okay, yes, but the males does look a little asymmetrical, and we're going to talk about that because there is definitely an outlier in the males. And that's the 49. There's just like a 49 out there. So the way you find outliers is you're going to take Q1 and you're going to subtract 1.5 times the interquartile range. And you're going to do Q3 plus 1.5 times the interquartile range. Looks kind of weird, but what we're doing basically is we're going to say Q1, that was R37. And we're going to say 1.5 times whatever the interquartile range was, which is Q3 minus Q1. In this case, that's 2. So we're going to do 1.5 times 2, and then we're going to do 37 minus that. That's how we find an interquartile range. So 1.5 times 2 is 3, 37 minus 3 is 34. So that's kind of the lower limit of what we'd expect for outliers. If we have a shoe size less than 34, that would be considered an outlier. That's how you find outliers. And then you do the same thing with your Q3. And you would say 39 was our Q3 minus 1.5. We already found the interquartile range was 2.
It's plus 1.5.
Sorry, plus 1.5, thank you. And it's going to be 42 this time. So that's kind of our range for detecting outliers. As long as all the information is between 34 and 42, we don't have any outliers. That's kind of like our range for determining where outliers would exist. So for the women, all of the information does indeed fall between 34 and 42. For the men, I'll switch it to the men now. Q1 was 37. And we're going to do times the IQR. So I'm sorry, Q1 was 38, and it's 1.5 times 2. So the lower boundary is going to be 35, and then the upper boundary was going to be 43, I think. Oops. And when we get the upper boundary of 43, that's when we'll see, hey, there's definitely one outlier. It's this sucker over here, this 49. That's how you can determine where outliers are. And what you can do as a result, when you have an outlier, you can actually replot your graph. And I'll show you that real quick. And you can plot the exact same graphs, but now we're just going to highlight that there is indeed an outlier. So 30, 32, 34, 36, 38, 40, 42. All right, so the women's graph didn't have any outliers, so it should be the exact same. It's going to start at 34. It's going to have its Q1 at 37, median at 38, Q3 at 39, and its max at 40. The men's graph, all right, is now going to be, it's going to take the new max is 42 because that was the max before we got to the outlier. So we're just going to take the outlier 49. I'll just put a little X over here at 49. That's where it used to be. The new max is going to be 42. The min stays the same. So our min was 37. And then our Q1 was 38. Q2 was 39, or median was 39. And the Q3 was 40. And whenever I do these, I always like to kind of draw the 5 lines first and then create my box out of the middle 3 and then draw my whiskers. And that's going to be a little more representative of all of our data is by drawing that there is definitely an outlier there. Okay, that's the idea here for this particular problem. Okay, and if you wanted to, we can always label these as well. If you want to, you could say, hey, this is the min. There's my Q1, my median, my Q3, and my max. Okay, that's where our points are represented on the graph when we're drawing them. Okay, you don't need to label that, but that's just a quick reminder of our 5-number summary and how we're finding those 5 points. Okay, I know, a lot, just not hard, I think. It's just a lot of information and it's a lot to remember. I think that's the best way to describe it here. I wouldn't say it's crazy difficult, it's just a lot. Okay. And that's kind of the way this course is going to move all year. We're just going to have a lot of stuff every day. Especially we're going to be moving twice as fast since we're getting through the whole year in a semester. Okay, but we see you every day, so that's why we do it. All right, last thing today we're talking about is cumulative frequency. And that's the sum of all the frequencies up to a particular value. And then we're going to draw something called a cumulative frequency curve. Okay, perfect color choice. Let's go with black.
Anna has a question in the chat.
Oh, okay, sorry about that. There is a question in the chat. Thank you. Is there more than one outlier? Do you put more than one X? Yes, absolutely. So you're going to do X's for all the outliers. So anything that falls outside of that range when we do that calculation with the Q1 and the 1.5, you put X's for everything that's outside of that range. Great question. Okay. All right. Okay, so now what we want to do for example 11, it says The number of visitors to Hales Castle was noted on 200 separate days of the year. And we have the information on the right-hand side that says number of visitors and the frequency. It's all over here. Okay. Now it says, explain how you can tell that there were fewer than 100 visitors on 54 of the days. Okay. So the frequency is the number of days, and then this left side is the number of visitors. So, for example, I have 16 and 38. If I added those two together, 16 plus 38, that gives me 54. So what that's saying is I had less than 100 visitors on 54 of the days. So I'm just adding the two frequencies together. So adding them together shows that I had fewer visitors. I'll say less than 100 visitors. Okay, so that's what cumulative frequency is. We're just taking the frequency and we're just adding every single line. So that's how you would complete the table on part B. So just go ahead and add them together. So you have 16 and 38 is 54, and then add another 50. 54 plus 50, the third line would be 104. And then you're going to add another 36 to that, and you'll get the next line. Okay, that's how you would complete a cumulative frequency table. And notice that on the left side, the boundaries now, it's just an upper boundary. It doesn't have the total number of visitors range anymore. You're just adding them all together. Hey, well, how many days did we have less than 150 visitors? Well, 104 days because we're adding them all up. So go ahead and fill out the rest of this table, for example, 11. A cumulative frequency curve. And what a cumulative frequency curve is, just like it sounds, we're going to create a frequency graph. Whoops. Straight down. Straight over. All right, so on this side, we're going to call this the number of visitors. And on this side, we're going to call it the frequency. I'm just going to abbreviate that because I don't have much space. But notice that our cumulative frequency goes all the way up to 200 people. So we kind of want to make that our max. And then we'll start at 0 there. And maybe we count by, let's see, we can count by 20s. 20, 40, 60, nice easy number to count by. 80, 100. Gets a little tight at the top. Didn't give myself very much space here. Sometimes I'm really good at that. And then in terms of number of visitors, the upper bound is 400. So we'll probably want to go out here somewhere. Let's just say, I'm just looking at your book right now. I think your book has it by 30s, so we'll count by 30s. Just follow the book. 120, 150, 180. Jeez, I am not doing this great right now. Okay, can I erase that part there? Okay, try that again. Okay, so when we get our data set up here, we want to get it to at least 400. So there's 390, 420. There we go. All right, and what we want to do is we basically want to treat this like a plot. So we'll say, all right, at 50, there were 16 visitors. So we'll go to 50, comma, 16, and we'll plot a point there. I'll do this in a different color. At 100 on the upper boundary, the number of visitors, we had 54 frequency. And then when we got to 150, the frequency was up to 104. When we went to 200, the frequency was 140. So we just keep sketching our points. And then we went up to 172 when we got to 250. So yeah, we're just plotting points. That's the goal right now. And then at 300, it was up to 191. At 350, 197. And then 200. By the time we got to 400 here. And we basically want to draw a curve saying from zeros and just kind of connect to the points. And that's what like a frequency curve is going to kind of look like, a cumulative frequency curve. It picks up pretty quickly. Mine's really stretched out, so it doesn't look the prettiest. And then it'll kind of flatten out again at the top. Okay, and then it says use your cumulative frequency curve to find an estimate for the median, the lower quartile, and the upper quartile. So we're basically looking for halfway point, halfway through our data, and then we're going to look for half of that, upper and lower. So the way we do this halfway again, we're looking for the frequency of 100. So at 100, we want to find out where is this thing at. So it looks like it's going to be somewhere between, let me write this down, this is the median. Somewhere between 120 and 150. That's kind of where we're going to be at for the median. That's how we can identify it from this cumulative curve here. All right, just like how we did it before with our data table, we can do this as well with this graph. And then if we want to find Q1 and Q3, Q1 is going to be around 50. There's our Q1, and then Q3 is going to be around 150. Okay, and that's how we'd identify those values from the graph. Okay, so find the values on the x-axis corresponding to 100, 50, and 150 on the y-axis. That's what that part is saying in parentheses. And then we just kind of guess what our values are. So the median, I would say that's definitely closer to 150 than 120. So the median, I would say, is approximately 140, something like that. Okay. And it's just your guess based on your data. Q1 is going to be, let's see, I don't know, 92, 93? I'll say 93. And then Q3 is going to be approximately, I don't know, 215, something like that. All right, that's kind of how we tell where our 3 points are going to be. Now, if it were an assessment or something, I'm going to actually give you a graph and you'll build it and you'll have much more accurate numbers than if we're hand sketching it like we just did. Okay, but that's the idea for this particular problem. And then part E asks us to find an estimate for the 85th percentile. There's a little note in your textbook that says to find any percentile, you read the value on the curve corresponding to percentile of the total frequency, which is not very useful. The way I think about it more is that our maximum's 200 and we want to go 85% of 200. Okay, so if the maximum was 100, we'd go to 85. If the maximum is 200, we're going to go to 170 would be our 85th percentile. That's kind of how we'd figure out where the 85th percentile is. So you would just do 85% of 200 because that was our max. And then it's going to be somewhere over here between 270 and 300. So like maybe 280-ish. Okay. Would probably be our 85th percentile. Somewhere around there. That's just a guess. But that's based on my graph. That's how you'd find your 85th percentile. And your textbook actually says approximately 247. So my graph's a little off here. Not the best graph in that regard. Okay. But again, I just did 85%.
Wouldn't it be
of 200. I'm sorry?
Oh, wait, never mind.
So we do 85% of 200, that's 170. And then I use that to find that location on the graph. Okay, that's where the 170 comes in. So it's going to be like, it says on your, in your textbook, it's actually 280 or 247, but I guess 280 based on where my graph was. So mine was a little off. Okay, but that's the idea here. Okay, if you're told the lowest number of visitors was 25 and the highest number was 370, draw a box and whisker plot to represent this data. So just a quick box and whisker plot. We already have Q1, Q3, so in our median. So we know 25. We're going to say 93. And then 140. 215, 370. Not a very accurate box and whisker plot there. Because I want to say 370 would be way out there. So let me try that again. 23, 93, 140. And I'll just label this. This is 370 for our max. This was our 215, our 140, our 93, and our 25. And then we just, the last part was determine if there are any outliers. And that's where we're going to use that weird Q1 minus 1.5 times our IQR. And again, to find that interquartile range, we're going to say 215 minus 93. And in this case, it was 122 for our example. So our Q1 was 93 minus 1.5 times 122. That's a huge range, right? And I got negative 90, so that 25 is definitely within the range here. Okay. And then if I do the Q3 plus 1.5 times 122, my Q3 was 215. I got 398. So technically the 370 is not an outlier. It just squeezes right in there. Okay, so no outliers. That's how we would tell this last part here.